Hi DockerCon! Welcome to Integration Testing Made Easy with Testcontainers and Docker. My name is Denis Rosa and I'm developer advocate at Couchbase, which is one of the most popular NoSQL databases for mission-critical use cases. Testing has always been a controversial subject, and with the migration from monolithic architectures to microservice, it is undeniable that the way which we test systems has also changed. When I started working with software development, it was common to see a distribution of tests in a triangle format, like this one here, where at the base we have unit tests, then integration tests, and then integrated tests. In fact, it is still quite common to see this kind of distribution in monolith architectures. But when we talk about microservices, things change a little bit. In theory, each microservice should be simple, and with just a few unit tests, it is enough to cover the whole application logic. But on the flip side, you end up having to increase the amount of integration tests as microservices tend to have more external dependencies. That is why the distribution of tests in microservices tends to have a form of an hexagon or a honeycomb. Okay, you might be asking what all those things have to do with test containers. Well, one of the main characteristics of integration tests is that in order for them to pass, you need to previously set up the environment that contains all the required external dependencies. And that's exactly what test containers can help you with. With test containers, you can programmatically create the required environment for your tests. And the way it works is quite simple. It's really just a facade that runs Docker commands under the hood and waits until the container is available. Of course, you can do a lot of advanced stuff with it, but let's see how that works in practice. In the demo, I will be using the Java version of test containers, but there are versions for Node.js, .NET, Python, and etc. And as a good portion of you are most likely not Java developers, I will hide anything that is Java specific and try to focus on what is common in all languages. Okay, let me share my screen here, and this is the official website for test containers. The Java version is at least this is the website. And here is the repo that we are going to use on this talk. So DockerCon22-test containers. I will share with you in the chat as well. Let's go to our application on the IDE. So this application is just a simple microservice, which is part of a game app. We are storing here two entities, so game user and wallet. And those entities are stored on my second favorite database, which is Postgres. But I bet you guys can guess what is the first one. I already imported all the dependencies here from test containers because this is Java specific, so not super relevant for you guys. And my application automatically creates the tables when the application starts as well. All the code to store the entity is already here, so you don't need to worry about that. So everything is already there. What's really relevant for us is this test here. In this test, we are testing if we can save a user and if we can save a wallet. The problem with this test is that we need a database, right? So we need a Postgres instance. Let's request that via test containers. So in order to do that, what I need to do is to first add on the top of my tests here, test containers. And now I can say, hey, let's go do this here on the top. I can say public static Postgres SQL container. Let's call it Postgres. Then new Postgres SQL container. The constructor is deprecated here because we need to specify the image name. So in this case, will be Postgres. Let's pick 14.2. And we will specify here that we want this database with username user with password with database name test. And now I need to add here container. So test containers will automatically create this instance for me when we first run this test. And this database will be shared between all my tests here. Now we need to let our application know that it needs to use this container here. So this is kind of language specific and framework specific. In Spring, we do the following thing. So static void properties, just creating a method here, and then this method receives dynamic registry and call it registry. Then I annotate this method with @dynamic property source, and here I simply add registry dot add spring data source dot URL, and I call here Postgres get JDBC URL. So I'm just calling the URL that it will generate here. One important thing is that test containers assign random ports, so you can't simply connect to the default Postgres port. So you have to get whatever port test container gives you, and it does that to avoid any conflicts with ports in general. Now we also need to add the username and password, so let's do that here. Here is username, and then we can get username and password, and get password. Yeah, that's pretty much it. All we need to do is to run our test. So we can run our test here. You see the instance coming, and here on the container, you see that we already have here Postgres running. So this is done automatically, and boom, our test just completed successfully. Great, we just built our first test running test containers, but maybe that was a little bit too easy. So let's make things a little bit more complicated. Suppose that our game is a success and we are getting millions of users that, like myself, love to accumulate hundreds or even thousands of items thinking that they might need to use it later. We also want to monetize our game by selling coins for a lot of money. And to motivate users to play, we also allow them to profit inside the game by exchanging their coins for money. So here's the problem. We can't afford any issues with these coin transactions, as it might cost us a lot of money. But at the same time, we still need our game to be capable of saving millions of records of user stats and items per minute or even per second. So let's go back to our app and try to tackle the first problem. We will set the transaction isolation level in Postgres to serializable. This will avoid any potential non-repeatable reads, phantom reads, and serialization anomalies, which will make our coins transaction much more reliable. However, it will definitely make Postgres slower. So that's why I do not recommend you doing that unless you need a high consistent level. Jepsen has this beautiful chart here that lists all the consistent levels. So the higher you go, the better is the consistency, but of course, as everything else in life, you are trading off consistency by something else. In this case, it is performance and availability. Postgres supports monotonic atomic views, repeatable read, and serializable. But by default, Postgres comes with monotonic atomic view, which is exactly what you probably are using right now if you never change this parameter. The thing is, this is exactly the type of transaction that Couchbase supports. And the cool thing is, Couchbase is a fast, highly scalable, distributed database. And although we store data as JSON, you can still query data in Couchbase using SQL, which makes it a good fit to store our users and items. So our application will now store the wallet in Postgres and the user and items. We haven't added items yet, but potentially items inside Couchbase. I already, in this version of the product, added Couchbase here just to save on time, and also changed the code to use Couchbase now. So it's not super different than what you were supposed to expect. So here you see we have bucket. So bucket is similar to a schema in the database, and then we call collection, and which is similar to a table. So we get the game user table, if we can say that, and then we insert our user there. So this is not super relevant. It's pretty much what we expect from a database. What we really care about is our tests, right? So now we still have the same tests. However, we need now a Couchbase database to be able to run it. Cool. To add Couchbase here is actually super simple. So we can call first the bucket definition is equals to new bucket definition. And here let's call it my bucket. So the bucket definition is similar to a database name. So that's why we are creating this now. And now I can create my Couchbase instance. Let's call it a static Couchbase container Couchbase equals to new Couchbase container. We need to specify the image name, Couchbase server, maybe enterprise 7.0.3. Cool. And we specify that, yeah, with bucket definition. I'm not creating the username and password here because test containers will automatically generate one for me. And now we need to let our application know that, okay, I want you to use this instance here. In our configuration, we have this class here, Couchbase config, which is the attributes that our application are expecting. So I can come back here and say, and comment that, and copy here and say, okay, let's copy registry.add. And here we can call Couchbase get connection string. The next is Couchbase .get username. The next is Couchbase get password. And finally, we can add registry.add, and this is the bucket name. So bucket definition get name. Cool. And that's pretty much it. Now we can run our test. But before that, I still need to add the add container here. I almost forgot to add this annotation. So now we can run, and you see here the test is running. And the cool thing is that when I show you the dashboard, you can see test container allocating the containers here. So you see Postgres and Couchbase here. We are waiting for the containers to be available to create tables, create index. So here you see that, okay, we are creating the bucket and the indices in Couchbase. And here there is the application starting. And soon we should have our tests. Yeah, here we go. Both tests were successful. Okay, this demo is a little bit better, but well, microservice using two databases sounds a little bit awkward, doesn't? So this is a sign that we might need to break our app in two different microservices. The first one will be the wallet storing data in Postgres, and the second one will be our game user storing data in Couchbase. To save on time, I already split the project in two, and this one is the Postgres one, which is storing our wallet, and I already generated and pushed an image to Docker Hub. Cool. And then the Couchbase one, which is storing our user, is where the magic will happen. In our test now, we will create a game user and then call an external microservice to create the wallet, right? So here is one microservice calling another. As the microservice needs to talk to each other, the first thing we need to do is to create a network. So we can come here and call network. So network and then equals network dot new network. Then we go to our Postgres database and say, hey, Postgres, please use this network here that I just created. And let's give this instance a network alias. We will call network aliases. And here we will do something like, let's say, wallet microservice, maybe database, DB. Here's where the magic happens. We can create an instance of our wallet microservice here as well. So let's type public static generic container, which is something that Testcontainer provides. We still need to annotate this with @container. It's super important. And here we can give this name wallet microservice and new generic container. We need to specify the image name here. In this case is Denis WS Rosa wallet microservice, and let's pick the latest image. Now let's add those two instances in the same network and give an alias for this microservices as well. So with network aliases, and we can call this maybe wallet underscore microservice. We also need to say that this container depends of the other one, so container. This is the Postgres one. And the wallet application expects the credentials of the database as environment variables. So we can specify that with env, and in this case, we can specify data source URL. And here we can specify something like JDBC Postgres SQL. And then we can specify here the network alias of our database and the Postgres port 5432. The name of the database, and yeah, maybe let's add here logger level off, just because I want to. Cool. So one thing that is important to highlight is because those two containers are in the same network, they can access each other, and they can also directly access specific ports. So in this case, our application is directly connecting to the Postgres default port, like 5432. Cool. And we also need to specify here the username and password. So let's write something like with env, and then data source password, and then we can call container .get password, and with env data source underscore username container get username. We also need to let Testcontainer know when our container is available. In this case, we do have a health check in our application, and all I need to do is specify the health check here. So in this case, I can specify waiting for, and then say wait.for HTTP, and the endpoint in my application is called API/v1/health. And last but not least, I also need to expose the port of this container here, because my application needs to call this microservice. So I can specify something like with exposed ports, and then specify here 8080. One thing that is a little bit confusing is that our test is actually accessing this microservice outside of this network. So when we expose the port, although we are exposing the port 8080, test containers will assign a random port. So if we want to call this microservice here, we need to actually call get mapped port, and then we specify the port that we exposed here. And then it will give us the actual port that is mapped on our local machine. And this method here is simply calling a REST endpoint on that wallet microservice. So here we essentially, this REST endpoint just creates a wallet. So finally, we can come here and run our test. And again, we can come here to the dashboard in Docker, and you can see all the instances running. So let's go back to our test here. And you can see now we have Postgres running. We have the wallet microservice, and soon we should have the Couchbase one as well here. And now the wallet microservice is connected to the Postgres one, and we have our application here use the Couchbase one. So let's wait for our test. We should be almost there. So we already created the bucket inside Couchbase. Our application just started again. And finally, we created the index inside Couchbase as well. And yeah, here we go. Our test was successful. Congratulations. Of course, in a real world scenario, making synchronous calls is something that we try to shy away from, but I have seen many cases where we simply could not avoid that. This demo is just to show you how even in more difficult scenarios, you can still use test containers. But please try to make the communication between microservices asynchronous whenever possible. You could simply make them talk to each other via Kafka topics, for instance. And speaking of Kafka, let's see if test containers has support for Kafka. We can click on modules, and here we have databases. So here we have Couchbase, and here we have Elasticsearch, Hive, and Kafka. Here we are. So yes, we have Kafka support. So if your microservice needs to post a message in Kafka instead of calling a microservice synchronously, that's the container you would use. And if you see here, it's not that different from what we have done in the past, right? Testcontainers is an open source project. So if you're interested in it, please consider contributing. And if you want to learn more about Couchbase, go to developer.couchbase.com or on our room here at this event. Thanks a lot for your time, and I hope you had fun. See you soon.